All right, guys, I am going to go through a few examples on the video today. You can kind of skip ahead to any of the ones you think you might need help with if you just want to watch those, but wanted to make sure you had some video examples on each of these. So hopefully you watched the first video lesson with notes number 1. If you haven't watched that, you do need to go watch that one first. Watch through or look through the notes and make sure those things make sense. And then you're trying some of these problems on your own. So we worked on inverses or inverse functions and then also on logarithms, kind of a review on that stuff. So I'm just going to go through these examples and then you guys try some on your own. Okay, first chunk here, the first example. Directions are for each function, we want to find the inverse function. So on the notes, we learned that the best way to do that is to write this f of x. We're going to write that as y. So I'm going to write this as y equals 1 over x plus 3. And then to find the inverse, I'm going to switch the x and the y and then solve for y. So to find my inverse, I'm going to write this as x equals 1 over y plus 3, and then I want to solve for y, right? Okay, so let's see, different color here. To get y by itself, right now y is on the bottom, so I'm actually going to put that over 1, and then I'm going to cross multiply here, but I'm not going to distribute anything because I want to get that y by itself. So if I do x times y plus 3, I can write that as x times y plus 3 for one cross product equals 1 times 1 is 1, or you can think of it as I'm multiplying each side by y plus 3. That way I can get the y out of the bottom of the equation. I don't want it to be in the bottom, right? Okay, so then to get y by itself over here, I don't need to distribute in that x. I need to get rid of it. So I'm going to divide both sides by x. Those will cancel out, and then I'm left with y plus 3 equals 1 over x. Whoops, 3. And then to get y by itself, I got to subtract 3 on both sides. So I'll end up with y equals 1 over x minus 3. So my inverse function, or f inverse, would equal 1 over x minus 3. Ta-da! Okay, so remember, easiest way to find an inverse of a function, write it as y equals, switch the x and the y, and then solve for y. Okay? All right, so you guys can try that on the next 4 that you see there, same process. Okay, next type here is now we're given 2 functions. We've got an f of x and then also a g of x, and we want to know, are those 2 functions inverses of each other? So you've got 2 different ways you can go about figuring this out. Method number 1 is I'm going to just take one of the functions and find the inverse of it and see if it matches. So I'm going to go with the 3/4 x minus 1. So if I do y equals 3/4 x minus 1, and I want to find the inverse. So I'm going to switch the x and the y. So I'm going to make this x equals 3/4 y minus 1, and now I'm going to solve for y. So I'll add 1 on each side. It'll give me x plus 1 equals 3. I want to get the y by itself, so I need to get rid of that fraction. So I'm going to multiply both sides by 4/3. And make sure you do distributing on that side. So here the 3's cancel, the 4's cancel. I'll end up with y equals, and if I distribute that 4/3, I would get 4/3 x plus 4/3, right? Okay, so then I can look to see, is that a match? 4/3 x plus 4/3 would not be the same as, this looks like 4/3 x plus 1/3, right? So no, these are not inverses because those don't match, right? So there's one way to do it. The other way that you could check, if you want to see, so I can do method 2. Method 2 is we use function composition. So I'm going to plug one function into the other. So on this one, I'm going to do f of g of x. So I'm going to take and do f of g of x. So f of x is my 3/4, but then instead of x, I'm going to plug in g of x, which is 4x plus 1 over 3, and then minus 1, right? Okay, so then if I multiply that or distribute it, and actually I'm going to write that as 3/4. I'm going to separate these fractions. I'm going to make it 4/3 x plus 1/3 minus 1. And if I distribute the 3/4, 3/4 times 4/3, that's 1. So that would just be 1x. And then 3/4 times 1/3, that would make 3/12 minus 1. 1 would be 12/12. So then I get 3/12 minus 12/12 would be 1x minus 9/12. Or if I simplify that, 1x minus 3/4, right? And the reason we know if I end up with f of g of x equals x, then I know it's an inverse, right? That tells me it's an inverse. But I did not end up with just x. So if it's not x, then that means they are not inverses. Okay, now you don't have to do both methods. You can choose which one you like, but either way, we end up with that same answer, that they are not inverses. Okay, all right, so try the same thing on 5 and 6 there. See if you can do the same process. All right, our next one, we'll do some graphing with inverses. So I've got, it says sketch the graph of each function and its inverse function in the same coordinate system. So I'm going to graph both the function that it gives me, and I need to graph the inverse. And it tells me also I need to label at least 3 points on each graph, right? So this one I've got 1/4 x cubed minus 1. Now this is not a linear function, right? So that means I can't just use y equals mx plus b. When you get down here to like number 7, that's 3/4 x minus 5. That's just a linear equation. So you can use flip intercept there. 3 to the x, that's an exponential equation. So you won't be able to use y equals mx plus b on that one. Either way, you can always just make a table of values anytime you're trying to graph. So I'm going to, for f of x, I'm going to make a table of values here for x and y. And I'm going to try to be kind of smart about the values I pick. It said I need to label at least 3 points, right? So I noticed when I go plug in my x, 0 is definitely going to be an easy one to plug in. And then maybe I should pick both a negative and a positive number to get 1 point on each side. So when I think about what number to plug in here, if I pick 2, when I do 2 cubed, I'll get 8. And then I got to multiply by 1/4 or divide by 4, and 8 is divisible by 4. So I'm going to go with -2 and +2. Okay. If I go any bigger than that, or if I pick a 1, then I end up with a fraction. It doesn't really matter what number you pick, but I'm going to go with 2 just to give me some nice numbers. Okay, so then when I plug those in, I do 1/4 times -2 cubed minus 1. That will give me -2 cubed, -2 times -2 times -2, that's a -8, right? So this would be 1/4 times -8 minus 1. -8 times 1/4, that's like -8 divided by 4, which is -2. And then -2 minus 1 would give me -3, right? 0, so that means I'm going to do 1/4 times 0 cubed minus 1. Well, 0 cubed is 0, and then 0 times a fourth is 0. 0 minus 1, that gives me -1. And then 2, 1/4 times 2 cubed minus 1. Well, again, like before, the 2 cubed is 8. 8 times 1/4 is 2. So then 2 minus 1 gives me a +1. Okay, so there's my points I'm going to plot. So got -2, -3. So our first one there. And I've got 0, -1, and 2, 1. Right? And if you remember from the notes, this is that cubic function that kind of has a curved kind of feature there in the middle. It'll look kind of like this. And I probably won't ask you to do anything like this, on the test or anything, but just so you know kind of what a cubic function looks like. Trying to make it a little darker there, but that's okay. Okay, so So there's our cubic function, right? Okay, that's my original function. Now, I don't have the equation for the inverse. I could find it, like we did before in the problems earlier, or to do the inverse, remember, I can do f inverse of x, and all I have to do is flip the x and y values that I already had, right? So all my y values become x values, and my x values become y values. So now over here, I'd have -2, 0, and 2. And then my y values, which are now going to become x's, are -3, -1, and 1. So now if I plot those points, -3, -2, and -1, 0, and then 1, 2. Right? And this one is going to go this direction. Woo. Okay, so you end up with that inverse function. And remember, you can kind of tell because you get this axis here, this symmetrical thing that kind of goes through the middle. It helps you see it. But that's our inverse function on that one. Okay. Okay, so try the same thing on the other two graphs. Remember, number 7 is linear, so you can use your slope and your y-intercept there. Number 8 is not linear, so you're going to want to probably use a table of values. But remember, once you get the first function graphed, just switch your x and y values, and you can plot the inverse. Okay. All right, then our last section here was our review over logarithms. So on this stuff, the first one, all I want to do here is write it in exponential form. So it's in logarithmic. I want to change to exponential. Kind of gave you that little rhyme. If that helps you, your base becomes your base. The other two play switcheroo, right? Or you could always remember that the answer to the logarithm is the exponent. So you know that that -3 is going to be your exponent. And then I always remember that the base becomes the base. Those are the two most important parts. Okay, so if I change to exponential form, my base becomes my base. So 3 is my big number. The answer to the logarithm is -3. That means that is the exponent. So 3 to the -3rd equals the 1/27th. Right? And if you kind of think through that, 3 to the -3rd is 1/27. You should end up with a true statement. Okay, so those you don't have to do any math there. You're just rewriting it in the other form. Okay, same thing here, but now we're doing it the other way around. We're starting with exponential. We're going to change to logarithmic. And again, same thing. The base becomes the base. My base is 6. So I'm going to do log base 6. And then my other two switch sides. So the log base 6 of 136. And remember, the answer to a logarithm is an exponent. So my answer is -2. And again, you don't have to do any math. You're just changing the form. All right, and the last section here, we're actually going to evaluate the logarithms or actually get an answer. So all of your answers here should be a number. If it helps, you can always write it as equals x, right? Not necessarily solving an equation for x, but if it helps you to see it that way, that's fine. Okay, so best way to do this is, again, change it to exponential form. So my base becomes my base, right? So 36. And then the answer is the exponent. So it'd be to the x power equals, my answer is 6, right? So I want to know 36 to what power would give me 6? Well, this one's a little tough because my answer is smaller than what I started with, right? But if I remember, or if I think about this, I know that the square root of 36 is 6, right? Or I also know that 6 squared equals 36, right? So you can kind of think of those two things. This one's more helpful to me. So if I'm thinking of the square root of 36, that's the same as saying 36 to the 1/2 power, right? Would equal 6. So in this case, that x would have to be 1/2. Okay? So think of the base to what power equals another number, right? 36 to what power equals 6? That'd be 1/2. Okay? All right, so hopefully the LIM stuff is kind of a bit of a review from first semester. I know it's been a while, but hopefully that stuff kind of comes back to you a little bit. Let me know if you have questions on the inverse function stuff. That part's a little bit more new, hopefully not too challenging. Okay, I will be around. Let me know if you need help, and I will talk to you guys soon.